Sounds good.
You can start. It's all yours.
All right. Well, thank you everyone for joining me this evening. My name is Andy Yoon. I'm a Senior Solutions Engineer with SentryOne, and this is T-SQL tips and tricks to make your life easier. And thank you again to the Malibu User Group for inviting me to speak tonight. It's a great pleasure to do so, and I'm happy to be here. So just wanted to mention a little bit about myself. I work for SentryOne. In fact, I only started with them about 6 months ago. And actually, I've been a DBA and a DB developer for the past, 15 years or so, working with SQL Server. I'm an MVP, I do stuff in Chicago, blah, 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 blah. I tweet a lot. You can, see where I blog. You can email me if you happen to have any questions. I love talking to people. So one thing I just kind of want to mention briefly is that because SentryOne is a sponsor, I'm not going to do a whole long sales pitch or anything like that. But if you're not familiar with SentryOne, yes, hello? Hi, someone was jumping in. If you're there, if you can mute yourself, please, that would be helpful. All right, thank you. So in either case, because SentryOne is a sponsor of the user group, I just want to briefly say something about SentryOne. So if you're not using a monitoring tool of some sort, whether it be SentryOne or someone else, I strongly encourage you to do so, either as a DBA or as a dev. Because here's the thing. Good tools can give you insight into what's going on in your SQL Server. We don't always know our workloads very well, very intimately. And one of the things about SentryOne that I'm a big fan of, because I'm not only an employee, but I've been a customer 3 times over the years, is that it gives you the capability to really drill down very quickly to the root cause of your problems. It's a fantastic piece of software that there's so much functionality built into it that there's just a lot of different things that you can do with it. So in either case, the other thing about SentryOne that I also want to mention is that we have a free product out there called Plan Explorer. If you ever work with your execution plans, do check out Plan Explorer. It's absolutely free. You can get it off of the SentryOne website, and it allows you to really dig in deeper into your execution plans, much more so than the functionality that you get in Management Studio. And like I said, it's totally free. We don't even collect an email address from you, so we don't even track you. So anyways, that's it for the sales pitch. So thank you again for having me tonight, and let's get on with the show. That's my slides. There we go. Okay, so real briefly, I just want to go review our agenda for this evening. So this is, of course, T-SQL tips and tricks. So we've split into a couple of different chapters here. Chapter 1 is going to be covering SSMS productivity tips and tricks. Chapter 2 is what I'm calling T-SQL anti-patterns. And Chapter 3 is clever solutions to common but not easily coded challenges. And if you have a shorter title for that, I'd love to hear it. But in either case, I want to be clear that this is a 100 to 200 level session. On the other hand, even if there are some advanced T-SQL developers in the audience, my hope is that if nothing else, maybe there will be that one nugget of information, or maybe something you saw a couple of years ago but forgot about. So hopefully you'll see at least something, regardless of the level of experience that you happen to have, and get something out of this session. So I'm going to lay out a few ground rules. I will move fast in this session. That's what this session is intentionally built that way. You can go get my scripts right now from this URL, or just remember GitHub and SQLBeck, and you can find my scripts there. So you can follow along at home if you like. Or you can use my scripts later on and review them as you like. They're very well commented, as you will see. But like I said, I move fast. That's intentional, and that's because I'm really just kind of showcasing these tips and tricks. And you'll kind of get a feel for what we're doing and how we're going about it. Okay? With that, that's the end of the slides. Everything else is going to be in Management Studio. So let's get on with the show. Okay. So for this presentation, I'm going to be using an automobile dealership demo database that I have created. So it's a pretty simple, straightforward database that happens to have information about vehicles, inventory, sales history, things of that nature. I like to use it in a number of my different sessions. So example number 1, quick reference. So we have this simple select statement here with a couple of inner joins against the inventory, vehicle-based model, and vehicle model tables. And you've been given a task. You need to add a left outer join to the sales history table. And you also need to add what price a vehicle was sold for. So here's the thing. How many people here actually memorize all of their schemas, all of their columns, or do you remember whether you use underscores in that particular table, or the person who came up with it not use underscores? I don't remember all that kind of stuff. So, how do we find that information out really quickly? Well, you could be hardcore and write a query against sys objects, sys columns, and sys schemas. And as you see here, to look up the sales history table, we have the table name, and we also have the column names here. So this works. This is the hardcore approach, but that's not a practical approach. Or you could always use the GUI of Management Studio. We can click and open up Object Explorer. I can go find my database here, go into the tables, blah, blah, blah. And you know what? While this generally works, this is still kind of slow and clumsy. My demo environment here only happens to have 2 databases, but how many people here have servers that have dozens or even hundreds of databases that you might have to go digging through, or even just one database with hundreds of tables? That's not a lot of fun to go dig through to find that definition of what you need. So instead, I'm going to introduce you to SP Help. SP Help is a built-in function within SQL Server. So if I execute SP Help against sales history, this is what I get. So what SP Help shows me is a bunch of information about this particular table. I get all of the different columns, their corresponding data types. I see that this particular table, for example, has an identity column. I can scroll a little bit further down, and I can see information about the indexes that are non-clustered indexes that are on this table, and the constraints that also happen to be on this table. So SP Help is a really nice, quick way to get at those columns and get at that information. But here's the thing. Typing out exec SP Help is also still a little cumbersome. It's not as elegant, but there's a way around that. Keyboard shortcuts. Keyboard shortcuts are awesome. So for that, I'm going to go up to Tools, Options, Keyboard, and Query Shortcuts. I'm going to zoom it. So as you can see here, within Management Studio, we have these 3 keyboard shortcuts that are already baked in, and then you can see that I've added in a whole bunch of others. So these are all my custom query shortcuts that I like to use on a regular basis. So what can that do for us? Let me show you. So now I can just go back to sales history. I can highlight it, hit my keyboard shortcut for SP Help, and bang, I've just executed SP Help. So why is this important? Because again, we don't memorize our schemas. I certainly don't. I don't have a photographic memory. If you do, then kudos to you. But in either case, this is a great way just to quickly get at that information. Because the thing is, again, I don't memorize all that stuff. So if I'm reading through a stored procedure or a query, I might go back up here and look at the inventory table. What's in the inventory table? I can hit SP Help, and I have that information right at my fingertips.
Andy?
All right. So that is example number 1. These are the types of tips and tricks that we're going to be going through. So, hopefully you've enjoyed this so far. So, all right, example number 2. Let's go.
Andy?
So yes, go ahead.
One thing to note, again, this is not really the new creating shortcuts. It's only the shortcuts that you're going to enter are only going to work with a new window.
That is correct. You have to open up a brand new window, but on the other hand, once you've set those shortcuts within Management Studio, you're good to go from here on out.
Yes.
In fact, I actually have a blog post that details all of the shortcuts that I like to use. I wrote it for a T-SQL Tuesday about a year or 2 back, where I talked about not using the defaults. So if you want to find out which shortcuts I personally use, you can go check out my blog and read up on that too as well. So. All right, so example number 2, no select star. So, we have this query here of, we're selecting, top 1,000 from a view, all sold inventory, and we're dumping it into a temp table, right? And we're told that, select star is a bad thing, so we have to refactor it, okay? So we need a list of columns. Well, can I use SP Help? Actually, I can't. I can't necessarily use it against this temp table here because it's a temp table. So with SP help, you against a temp table, you have to actually make a slight adjustment. You have to execute it in this manner using with an explicit reference to temp DB. And now I have my temp table here. And in fact, I actually have that mapped to a different keyboard shortcut as well. So now I can copy out all these column names, paste them in here, or paste them in my query, I should say. But here's the thing. Now I have to go back and manually add in all of my commas. That's not fun. And I have what, a dozen columns here, but what if I had a table that was extremely wide and that had 100 columns, or something insane like that? So this is the time when actually using the GUI would actually be better. And let me show you. So first we're going to go to that view, also inventory. And now we see the columns here, but I'm going to grab the columns folder, and I'm just going to drag that here. And now Management Studio generates a column separated list for me. So now I don't have to mess around with adding in commas manually after using SP help. So this is another alternative way where using Object Explorer may actually be a better alternative rather than using SP help in order to get all of your columns back. All right. So I'm just going to clean that up. All right. Example number 3. So for this, I'm going to spin up a workload in another window. And then while that workload is running, let's pretend we're a DBA and we have, we're being told, hey, stuff is slow on my server right now. So many of us, like myself, will run add a mechanics SP who is active. So oftentimes, I'll execute SP who is active and I'll keep executing it because I'm waiting for something to happen. I'm looking to observe something, perhaps, while this performance issue or whatever, whatever happens to be going on. So I have to execute this over and over and over again. And frankly, I'm kind of lazy. So you know what? I'm going to use this little shortcut. So we're going to write exec SP who is active with go, but after the go, I'm now going to add a number. And what will happen is that the number will now cause the batch, which is exec SP who is active, to run that many times. We actually have an execution loop here, as you can see from the messages pane. So while please don't ever use this in production application code, this is really great for those ad hoc scripts, those one-offs, those little diagnostic things that you may have to run every now and then. Now here's the thing, do you want to wait? Because obviously this runs as fast as it possibly can. So you can always add a wait for delay and do this. Pardon me. Apologies, I'm fighting a minor chest cold here tonight, but you know what? I'm still here and the show must go on, right? In either case, so now that you see that, we have a 1 second delay in here. And so you can use this methodology to, you can script this out, save this into a toolbox file, and just copy and paste it into your Management Studio whenever you need it, or use snippets if you want. Okay, example number 4, I call this vertical horizons. Let's pretend we've been given a list of VIN numbers, maybe out of, I have to copy this out of Excel, and when we copy it out of Excel, and I need to dump it into my in clause query here, it's a tab delimited output here. So, what I would have to do is manually do all this nonsense where I have to add in the single quotes and, blah, 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 blah. That's not a lot of fun, especially if I have a long list of VIN numbers. Or I could, manually massage this data inside Excel, but that too is not fun. So here's a cool little trick. I'm going to hold down the Alt key, Alt again, click and drag in the middle right here. And notice this is, I'm dragging down. I've now selected a vertical selection within Management Studio. So now that I have this area selected, I can type single quote, comma, single quote. And I've just vertically edited all of that. I'm going to do the same over here. 1, 2. Same on this side. We'll add in a single quote, get rid of that last trailing comma, and bang. Now I've been able to vertically edit that VIN list very, very quickly, dump it into my T-SQL query without having to, change around the formatting or mess around with that. And, the whole vertical editing is actually a really, really handy thing. And if you're like me and maybe you use Ultra Edit or Notepad++, or, some of those other editors also have vertical editing capabilities built into it as well. So.
Bless you.
Like I said, apologies about that, but hey, the show must go on.
Come on, go on.
All right. So example number 5, give me all the things. So the task that we've been given is that we need to script out a bunch of views. So, what I can do, most people will just come out to Object Explorer, and I can right-click on one of these views, and I can do a script view as, and I can create it and put it into a new query window or save it out to a file. If I have to do a bunch of these views, doing this one at a time is extremely cumbersome. It's not very efficient. So here's a feature inside Management Studio that I actually didn't know about until only a couple of years ago. I'm kind of embarrassed to say. So if you go up to View and Object Explorer Details, so what this brings up is that it brings up a details pane that's very similar to the Windows Explorer. So now I can see, for example, if I click on Views over here, all of the detailed information, much as if I was using Windows Explorer and the File Explorer, now I'm seeing all of these different objects. So now what I can do is highlight and select a bunch of my different views, script views as, and then I can create them all right here. And now I have one query window that has all of my selected views in them. Even cooler, if I go up to, say, Tables, I can actually bring in a couple of extra columns, so I can quickly use this as a reference for row count, for example, data space used, for example. So now I can even use this as a reference, like I said, to take a quick look at the different tables that are in my database. So, Object Explorer Details is one of those things that, doesn't get a lot of attention, but it's actually really cool and, could use some love. So that's why I chose to highlight it here. All right, so that brings us to the end of Chapter 1, SSMS productivity tips and tricks. So this is a good time to pause and ask, are there any questions?
Andy, one thing to note is that you can delete the objects from the Object Explorer as well.
Yes, that's a great point as well. So, for example, things can be deleted, dropped, and renamed here as well, just like any other file explorer, if you will.
Yeah.
Are there any other questions in the chat?
I see no questions in the chat. I can unmute all just to see maybe somebody wants to ask a question. Any questions for Andy?
All right, doesn't sound like there's any questions. So if you want to mute everyone again, we'll keep going. So, all right. Guys hear me again? It looks like I was, there we go. You muted me as well. All right, let's move on. So Chapter 2, T-SQL anti-patterns. So these are all things that whenever I see them in code, I kind of pause and go, is this something that I need to pay attention to or be concerned about? I'm going to go to the automobile dealership demo. And example number 1, sort it my way. So I'm going to do a quick little bit of setup here. I'm going to create a table called sales summary. It has a VIN number, invoice price, sell price, transaction date, and it's clustered on the VIN number, okay? And then we also need to turn on actual execution plan for this. So what I'm going to do is I'm going to do an insert into the sales summary table that I just created. Don't ignore the select statement, but the one thing that we're doing here is that we have an order by, and we're ordering by transaction date descending. Ignore the max stop. And then I'm also going to run the same exact insert again, but I'm also going to run it without the order by statement. And let's see what happens. Let's compare and contrast. So if I look at the execution plan, I only see one sort operation. That's a good thing. I'm sorting, the first query at the top is ignoring the explicit order by transaction date, and we're only sorting by the VIN number because we're inserting to a table that has a clustered key, and that clustered key orders all of my data by the VIN number as we define the clustering key. So that's a good thing. But does that always happen? Let's find out. Because here's the thing. what version of SQL Server are you running? I actually happen to be running SQL Server 2017, and to be extra fancy, I actually happen to be running it on Linux as well. Ooh. But here's the thing. What if you're running an older version of SQL Server? Simulate that. So I can change the compatibility level of my databases. In this case, automobile dealership is currently set to 140, which is SQL Server 2017. But some of us are still stuck on SQL servers that are run 2008 R2. So we're going to drop down to that compatibility level, and then we're going to rerun the code example above. And this is where I show you my sad face. The query optimizer in SQL Server 2008 R2 and older will actually do 2 sorts. It's not smart enough to get rid of that extra sort. So I do a sort by transaction date, and then I resort that data again by the VIN number. So I'm doing extra work even though I don't have to. That's why this is a T-SQL anti-pattern. Again, if you're on 2012 or higher, you don't have to worry about this. The query optimizer has been corrected to mitigate this behavior. But if you're on an older version of SQL Server, this is something that you're going to need to watch out for. Now, do you think we'll have a similar behavior if we have a heap? So I'm going to create a sales summary heap table. Again, that means it's a table without a clustered index, which means the data inside is completely unordered. We're still in 2008 R2 compatibility mode, and I'm going to do some very similar insert statements, one with a order by and one without an explicit order by. And if we look at the execution plan again, we see that the first query with the explicit order by has a sort in there again. But here's the thing, because a heap is unsorted data, we don't need to do a sort at all. And that's why the second query just gets rid of that completely. And if I jump back to compatibility level 140, you'll see that behavior in the revised query optimizer, in the improved query optimizer. You see now that the execution plans are identical. We don't incur an extra extraneous, worthless sort operation. One moment. All right. So, moving on. You turn this off. So, example number 2. Sort and sort again. So I have this simple query against the inventory and sales history table that's ordered by the VIN number. Let me show you the output of that. So here's the thing. I've been talking a little bit about sorts in the prior example and this example, and what's the big deal? Some people are wondering, do we care about sorting? It's just another, what's the problem with order by? Well, the thing is, sort operations in SQL Server are very, very expensive. And I have a number of different ways to show you that, but I'm just going to use a very simple example using set statistics time on. Some people, when they're looking at query time execution, they will look at the execution time down here in Management Studio in the lower right. This is actually inaccurate. You should not rely on that for measuring your query performance. Why? Because there's additional time from between SQL servers sending data back to your Management Studio. And honestly, Management Studio has a certain behavior that results in it being very, very slow to pull back data. So as such, I use set statistics time on to show me the actual amount of time that SQL Server has spent processing my query. So I take out of the equation the time of SQL Server sending data back to me. So using that, I'm going to turn that on, and then I'm just going to quickly use this to show you the cost or the timing difference when I run this simple query with order by and without the order by. So if I go over to the messages pane, you can see that the CPU time and the elapsed time is about 1.1 seconds of the first query with the order by. And the second query is actually a little bit faster. So again, it's not a huge improvement, but it's a fairly significant improvement. So 30%, if you think about it from a percentage perspective, 30% less time on the CPU, I'll take that. 10% savings on elapsed time, I'll take that. So again, it may seem these are simple examples, but here's the thing. Have you ever asked yourself, where is this data going? The output of this query, is it, for example, being consumed by a web application that already has web controls where the application is resorting the data on the fly after you sent it? So if it already has web controls to do sorting, why are you sorting it in SQL Server? Let the app layer sort that data for you as opposed to incurring that cost within SQL Server. Because unfortunately, ordering data in SQL Server is very, very expensive. So these are kind of things to think about, is where's my data going? Think beyond just your code. Think about the consumer of that data. All right. So example number 3, I call this, where did my day go? So I've had a lot of fun with dates and date issues over the years. So we're going to be looking at the transaction date, sales history, because we want to find all the sales records, or the count of sales records in December 2014. So I'm using this simple between clause here, between December 1st and December 31st. And at first glance, you would think that this would return the data that I want. And I'm going to turn off actual execution plan because I don't need that. But here's the thing, this is wrong. Why? Well, let's look at the data type of transaction date. Remember SP help, by the way? So transaction date happens to be a date time data type, not a date data type. So because it's a date time data type, we have to take time into account when we pass it different hard values. So what are the real values that we're passing in when I pass in these two strings? Well, if I use cast, I'm now passing in midnight of December 1st and midnight of December 31st. But there's a problem here. I now miss out on everything else that has actually happened on December 31st itself, after midnight till right through the rest of that day. So if we extrapolate the query, this is what it really looks like. I'm saying between this December 1st and between the beginning of December 31st. So that's where the code defect is. So how can you fix this? Well, one way you can do it is, if you still want to use the between clause, you can explicitly set the time. Mind you that date time has precision only out to every third of a what is it, a microsecond or whatever it is. So that's why it's a 997 and not a 999. So now we can see the number of records that just occurred on December 31st, the number of records we missed out on because of our code defect. So there's a couple different ways you can do this. Some people will still use the between functionality. I personally shy away from that. I actually much prefer doing a greater than or equal to the hard date, and then I'll do a less than the day thereafter at midnight, because I'm kind of lazy again and I don't want to type in the 997 blah 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 blah. So this is actually how I'll go about doing it. So now, if transaction date was a date data type, this wouldn't have been a problem. And that's why it's important to double check your data types. And that's why it's important to use SP help, because again, I don't memorize all my data types and schemas. Do you? All right. Okay, moving along, example number 4, how long and who cares? So have you ever seen the syntax of someone declaring a varchar but without a value? I've seen this before, primarily from app code that generates T-SQL as opposed to handwritten T-SQL, but this is something I've encountered before. So let's find out what kind of behavior we actually get when we have code that actually does this. So I'm declaring my value and a longer string. Hey, we have some truncation here. Instead of Andy and this much longer string, I'm only returning A and T. But there's something else missing that I'm even more terrified of. Do you guys see an error anywhere? There's no errors. So SQL Server has truncated data, but it hasn't complained about it. So if this is happening in your application code, you could be losing data. And us as data professionals, that's one of the most terrifying things that we could face, especially without knowing that we are losing data because we have no errors that are being returned. So if I make use of cast or convert, I'm going to cast as varchar and then convert as varchar just to experiment to show you what happens when I use cast and convert. I'm doing a cast here, and then I'm doing the length of that cast just to show you what that actual length is. and then we'll do a convert and then the length of the convert. Oh, we have a different behavior here now. If I do a cast and a convert, now we have a string that's 30 characters long, but we still have truncation and we still have no error. So if you have this kind of behavior in your application code, in your T-SQL code, you could be dodging a bullet here and losing data without even realizing it. And again, this is kind of terrifying because you capture at least 30 characters. Well, if the majority of your inputs are 20 characters or less than that, again, you're dodging a bullet. But maybe one day you have a client that comes in and does something that exceeds 30 characters. You've now lost data and you don't even know about it because you have no error. So one final example, what about a table? So let's create a temp table, and I'm going to create a column 1 as a varchar, and column 2 also as a varchar without a value, but I'm also going to give it a default constraint as well. So with the default constraint, it still works okay. I don't get an error back, fine. Let's insert a value into column 1, and then I'm also going to insert a value into column 2 using the defaults. Yay, we finally get an error. This is the time that I want to get an error because now SQL Server is finally telling me that data, the string will be truncated, which is what I want to know. And the reason it's going to be truncated, if we double check SP help, is that this has been created as a varchar 1. So in either case, the moral of the story here is always whenever you're looking at any kind of varchar, nvarchar, char, whatever, make sure that there's a number after it. All right? All right. Okay, moving on. Example number 5. Select that select. So I'm going to turn the set statistics time on again. And what we have here is a pattern of we have a select statement, and then within that select statement, we have yet another select statement against sales history. And it's correlated back to the inventory table. Okay, let's see what happens. So this took about 5 seconds to run. And we spent a decent amount of time, both in elapsed time and CPU time. Hey, perfect example of, hang on, let me zoom in. Zoom it. The elapsed time was about, 4,000 milliseconds, but notice down here, Management Studio told me 5 seconds because I had to return 400,000 rows back to Management Studio. That was that 1 extra second of overhead. That's why I don't use that. Anyway, so what I'm going to do is I'm now going to show you the cost of this kind of anti-pattern of a select within a select, because this is actually a terrible anti-pattern. And to do that, I'm going to use something called setStatistics.io. What that's going to show me is the amount of work that SQL Server has to do in terms of data pages. Because when I'm query tuning, I'm not looking at the number of records that were returned. I don't care about that. And if you check out my data type session, go over to SQLBits.com. There's a recording of it over there. I talk a lot about why we need to worry about data pages, not data records, when it comes to measuring the amount of work that SQL Server does from an I/O perspective. So to measure that, we're going to use setStatistics.io on, and I'm going to rerun this query. So what we see is that we actually have a scan count of 435,000, which is the number of records, and we also have an insanely large number of logical reads. What SQL Server is essentially having to do is that it is running this internal sub-select statement individually one time for each record that we get from the outer select statement. We're doing this in what's called a rebar or row by agonizing row fashion. This is extremely inefficient. It's an iterative approach that we don't want to do. SQL Server is set-based after all. T-SQL is set-based, so we want to leverage those strengths. So how can I write this differently? Well, I can just simply use a join. And using this join methodology, let's compare and contrast that. You see that it ran much faster, sub-second, and the number of logical reads was also a fraction of what we had to incur in the prior example. I didn't go through this row by agonizing row. SQL Server approaches from a set-based approach and was able to do things in a much, much more efficient fashion. So the moral of the story, a select within a select is a bad anti-pattern because of this row by agonizing row behavior that we see in T-SQL. Okay, so that brings us to the end of the anti-patterns chapter. So I'm going to check the chat real fast just to make sure that we have no questions at this time. Thank you, Elena, for the compliment that you have no questions, but that you're enjoying this. I hope you guys are all enjoying this. So thank you very much for that. I'll give folks one more moment to type in any questions if you happen to have any. Otherwise, we'll move on. Okay, doesn't look like there's any questions, so let's move on. Chapter number 3, clever solutions to common but not so easily coded challenges. So here's the thing, myself as a DBA, I happen to have a huge repository of T-SQL scripts, diagnostic scripts, little code snippets and things like that. I call it my toolbox, right? And hopefully all of us have something like that. And if you don't, start one up. I store mine in Google Drive. You can use OneNote or OneDrive or whatever you like. But in either case, what we find in this specific chapter are a lot of really cool code snippets for situations that you encounter maybe once in a blue moon. So it's one of those things of like, yeah, I remember dealing with that a year or two ago, so, but I don't remember exactly how I dealt with it, but I remember that I saved it in my toolbox and I have an example of it. So that's what this chapter is all about. Some of those interesting situations that, again, you only encounter once in a blue moon, but it's useful to have saved in your toolbox because you're not going to be coding it every single day. All right, so automobile dealership demo. Chapter 1, or example number 1, fun with output and inserted. So what we're going to do is we're going to create two temp tables. One is just temp destination 1 that has a record ID with an identity column, and it's starting at 1, but I'm incrementing by 3 instead of incrementing by 1. I'm doing this to intentionally illustrate something, and then we're just going to store VIN numbers. And then temp destination 2, we have, again, another rec ID, but then we have the inserted rec ID, which is not an identity column, and you'll see why in a moment. And then we have VIN numbers again. So this is what I'm going to do. I'm going to insert into temp destination 1 the VIN number, and I'm going to select top 1,000 VIN numbers from inventory, but then I'm going to output rec ID VIN from inserted and insert those into temp destination 2 and the columns inserted rec ID and VIN. And this is all one statement. So if I run that, one single statement, if I run the select statement against temp destination 1 and temp destination 2, I now have records inside both tables. And notice the corresponding inserted rec IDs. You remember how I mentioned that I'm incrementing by 3 to illustrate how we're taking these seeded values and immediately pulling them over. So why am I showing you this? Well, here's the thing. This can be very interesting behavior, if you will, because what we have here is this inserted table, if you will, is created and stores data whenever you do any insert operations. There's also a deleted table as well. Primarily, this is used with triggers, but this can be leveraged in your regular T-SQL as well. So by using output, inserted, and deleted with your DML statements, you can do some really interesting creative things. Well, like what? Simple example. What if you happen to have a deployment script that has to go out and you have to make a whole bunch of data changes to a key table in your application, right? But your business is a little gun shy. So with either maybe the data that you're updating or deleting, they want to make sure that you save that data off somewhere else. It's a reference table or something like that, right? So, we all take backups, of course, but if this is a massive terabyte, many terabyte database, and we just want to save this one small little reference table, I don't want to have to restore an entire database for that. That's a huge pain. But what I can do is in my deployment script, I can make use of outputted, inserted, and deleted to say, save off the data that I'm modifying, or the original data, I should say, and maybe store that in another table that is temporary that I can delete maybe a month later once the business, business owners say, yeah, everything is good to go, we can move forward, and you can get rid of that archive data. So this is a great little trick to archive information, or maybe you want to use it for auditing purposes as well. That's another handy use of this syntax. So, it's something that, again, you can be very creative with it, and it can really help you out whenever you're doing DML type work, insert, updates, and deletes. All right. Example number 2, horizontal aggregation. So, we're all familiar with T-SQL vertical aggregations, where we have a column and we want to take a max or a min or an average of all my vertical values. But what if I have horizontal values like this? So I'm looking at the inventory table and the sales history table, and for a given inventory ID, what if I want to know the max value between the invoice price, MSRP, and sell price? In the case of this record, it's the MSRP. In the case of this record is also the MSRP, but here it's a sell price. So how can I do a horizontal aggregation between all of these different values? Let me show you how. And there's a couple of different ways, but this is a really cool way that I found at one point in the past. We're going to use the values clause to do this. So what I'm going to do is I'm going to do a select, subselect, and the subselect is doing a select from values. And the values within values are essentially 3 of the columns that we are aggregating together. And then I'm declaring that, I'm naming it price array. Think of it as a table name or an alias, I guess. And then I'm also naming the values, I'm giving it a column name of price. And then what we're doing is that because we're selecting from this here, I'm taking the min of that price array price value, and that is my min price. Okay? So let's see what happens when I run this. As you can see, I get my min price. So this works. So that's pretty cool. I'm able to do that horizontal aggregation. But as you can see in my comments down here, didn't I just say don't do rebar, don't do selects within selects? Yes, I did. I did say that in the last chapter. But as we find with SQL Server, there's a lot of exceptions or edge cases, and this happens to be one of them. So let me show you the actual execution plan. I'm also going to turn set statistics IO on, and then we're going to rerun this. So first of all, from the messages pane, our logical reads is actually relatively low, a few thousand. We didn't do a crazy number of scans or anything else like that. That's good. So what actually happened was that in this compute scalar operator, because SQL Server already had those 3 columns retrieved from other operators, it was using the values clause to essentially do a poor man's pivot calculation. So it didn't have to create another construct. It didn't have to do anything because it already had those data points. So it didn't have to run another query. It wasn't a true subselect. I was only really computing a scalar operation against records or data that had already been retrieved using this values trick. So like I said, it's kind of a poor man's pivot, and if you're like me, I hate the pivot syntax, but it works rather well, and as you can see, it's quite efficient. So again, another cool example of a script to keep in that toolbox for that rainy day when you actually need to do a horizontal aggregation. All right. So let's see, I need to reset, turn this off. Chapter 3, comma separated tricks. So let's pretend we have 5 VIN numbers, and our application developer says, hey, we need to turn the, I need you to write a query for me to return this as a comma separated list. All right, fine. So there's a couple of different ways that you can go about this. And what we're going to do is we're going to make use of stuff, the stuff function, and XML. So first of all, I'm going to walk you through this step by step. So first, we're going to use for XML path, right? So I'm just going to append that onto the end of my query, and what you'll see as the result here is, my VIN numbers with XML around it. So that's step number 1. The next modification that I'm going to do is I'm going to prepend the comma in the front, and that gets us a step closer. So now we have a comma separated list. But we have a comma in the front now that we have to chop off and get rid of. How can we do that? Well, we could use substring, and so I'll have the substring of this string give me character number 2, and then go up to 8,000 characters. And that gives me my CSV list, and that's fine. But here's the thing. What if the string exceeds 8,000 characters? I've had situations where my data exceeds 8,000 characters. If that happens, we get a truncation error. So unfortunately, this does not work for us. So we can use stuff. You could use length. Some people may be thinking that, but if you use length, you must now break this apart into 2 separate steps because you have to get the length first, and then you can use substring after that. And again, if you exceed 8,000 characters, it won't work for you. We're trying to figure out how to do this all in one single step, okay? And the answer to that is using the stuff function. So what does stuff do? This is the only time I've ever actually used stuff in this context. I've never had to use it any other time in all of my years working with SQL Server. All right, so I'll walk you through this example. So we have this example string of A through K. This is my starting string. From the third position, I'm going to replace 5 characters, and then I'm going to replace it with this string. This is my stuffed string. So if I execute that, this is our output. So this is what it looks like, okay? So we can use stuff as a poor man's left truncate. So if I have a simple comma-separated list like we had before with a leading comma, comma Sadie, comma Jess, and I set my start position as 1, the number of characters to replace as 1, and I replace it with nothing, this effectively becomes a left truncate for me. I now no longer have a leading comma here. Yay! So let's bring that all together. So the final single statement solution is to use stuff. We will use the 1 and 1 to get rid of that first leading character. And what we pass it is this query with using 4XML path. And now we have our CSV list. Yay! So yeah, I can't tell you how many times I've used this snippet of code over the years. This is one of the ones that I've had to use a lot from my toolbox. Because again, I don't memorize the syntax, but I know where it is, and I just go and copy and paste it and adapt it. Okay, so let's take this to the next level. First, I'm going to do a bit of setup here and show you the sample data that we're going to work with. So what if we have this table of vehicle models and corresponding colors, and what if we needed an output for a single model name, a CSV list of the corresponding colors? So we have Camry here. I want 1 record with these 3 colors, but then Avalon only has 1 color, right? So I just want 1 record and the 2 color names in a CSV format. So I have to do some kind of grouping magic. Let me show you that. So what we can do is that we can make use of the stuff and 4XML trick again, but what we're doing now is, yes, another subselect, but in this case, we're doing essentially a self-join. So you see this vehicle list table that I created. I've aliased that as color CSV list, and that is joining against itself out here, which I've aliased as model list. So I'm returning the model list model name. I'm returning the CSV list, and then I'm grouping by model name. And because of this self-join, quote unquote, we get this behavior. Boom. Now I have my grouped, CSV list per model name. So this is a neat little trick of another way to, again, expand the CSV code that we just did in the prior example. And again, this is another good piece of code to store in your toolbox. Just remember that you happen to have it, and then the day that you need to use it, hey, I remember seeing that in Andy's session. I'm going to go pull that out of my toolbox. All right. Okay, example number 4, fun with string functions. So I'm going to create a temporary table called file path, and we're just going to store a file path in here. See my documents, blah, 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 my text file.txt, right? Nothing special here. And then what I need to do is that, I'm selecting out of this table, I need to get the file name only. That's my task here. So what can I do? Well, because with a file path, we don't know exactly how many folders we may have to deal with. In this case, I happen to have 3 folders. But what if this is a dynamic scenario where some of our file paths have 10 folders, subfolders, and it completely varies. So I can't do I can theoretically go through it row by row, but we want to approach this from a step-based fashion. So let's take a look at how we can do this. So one thing that's in common is the delimiter, the slash. So I can make use of char index perhaps. And if I make use of char index, and you'll see that I've added that as another column, that gives me the leftmost position of this of the slash. So some people might be thinking that now that I know this position, I can do maybe a recursive substring. Now I can, just grab this and then, keep going down and do some kind of recursion. And in an application world, that might be something I would do. I remember writing C code to do that kind of thing back in my college days. But again, this is T-SQL. We're going to do things differently. So instead, I'm going to drive in reverse. So I'm going to make use of the reverse function. I'm going to add in as a second column, as an additional column here. So when I have the file path reversed, this is what it looks like here. So let's build upon that. Because char index, remember, gives me the leftmost position of my delimiter. Well, now that I've reversed that string, I've added in yet another column here. Let's build upon our previous step. So now I have the right char index of my slash, which is right here. So now we're building up to, our final solution. So just to visualize this might help you to think of this as kind of an array. So, here's the numeric positions. Here are the positions of the character or of the delimiters. So really what we want is this. So what we have now is this value. So we can also calculate the full length and then do a little bit of math in order to derive this position. So if I do some simple math, so you see I've added in two more columns. One is the length of the file name, and then I've built upon that with the length of the file path, and then minus the char index of the reversed file path. I'm building each one of these steps into new columns as we go along. So now you see that the entire length is 55 characters. The rightmost delimiter is now at the 40th character position. So now what I can do with that is I can make use of substring with the file path, and then do the math that I did up here. I have to make a slight adjustment to the index because I want to drop the delimiter. And then here we go. And finally, I have my solution, my text file.txt. So that's pretty cool. And, this is, again, something that's kind of nice if I want to just grab a substring of something, such as file names, which is, again, something that I've run into somewhat commonly over my years as a dev. But here's the thing. Is this the best way? The answer is no. And some of you may even have been thinking about other ways to go about it. But here's the thing. I want you to, I did it in this fashion, this lengthier fashion, to also show you my methodology. Notice that as I've added on a different step, an additional operation, I've created a new column in my little select statement. So that way, if I happen to make a typo here and screw up, I know that this step and this step and this step were accurate. So I can easily go back to a point where I know I was correct and then continue to move forward again. Or maybe if I need to step back to this position or this point in my problem solving and maybe apply a different function, I can mess around with it in that way. So the idea is more to illustrate my methodology of breaking down the problem, and instead of just trying to write one big ginormous query all at once, break it up into smaller steps. Do something like this. So it's a methodology that I really wanted to share with you guys with this example. So like I said, yes, there's a couple of better ways to do this. A couple of my friends have sent me these. So for example, the most elegant way is to use the right function and then make use of reverse and char index. Or again, I can make use of reverse twice or 3 times. So there's no reason why I can't reverse and then re-reverse after I made a modification, right? In either case, all of these solutions will give me the answer that I need. But so, as we all know in T-SQL, there's many different ways to approach a problem. But again, I wanted to show the methodology of breaking down that problem, because if we've never addressed this before, done this before, we might feel a little intimidated, and that's perfectly okay. Okay, so with that, we are actually at the end of this particular chapter, and actually that brings us to the end of the session as well. So with that, I just want to again show you the URL for the scripts. I know I moved fast, but again, you can go get the scripts. You'd see that I've commented them very, very well, so it's very easy to go back and replicate all the activity that has happened here. So I'm going to pull open the chat and make sure that there are no questions. I don't see any questions in the chat. I'll give you all a minute or two if you happen to want to type one in. Going once, going twice. Okay, then. Well, then in that case, that's almost exactly 60 minutes. So it looks like I did well on time. So I just want to thank you again for having me. I hope you all enjoyed this session. Feel free to tweet about it and whatnot. That's great. And if there's any feedback that you happen to have, please drop me an email, whether it be positive feedback or even negative feedback. Because here's the thing, I want to know how I can improve this session. I'm always constantly trying to improve, and without hearing back from audience feedback, it's kind of difficult to know what I need to change. So if any of you guys happen to have any suggestions, things you would like to see done differently, etc., please share that with me. I would love to hear from all of you. But otherwise, again, thank you all for having me. And Steve, I'll hand it back to you.
Thank you. Thank you. I personally enjoyed the values with array list.
Excellent. Glad to hear that.
I still think that he can only use it inside the automobile industry with MSRP, selling price, and invoice, but
it's a simple example, but hopefully it gets the point across of the
yes.
horizontal aggregation.
Yes. And would you be able to send me the link to your GitHub?
Yes. So it's up here again. All you have to do is just search my Twitter handle, SQLBeck, and then github.com. So it's github.com/SQLBeck. Super simple, super easy to get at. And then you'll actually find that other scripts from my other sessions are also available up there as well. And in addition to that, a copy of my demo database as well is also available to you there. So everything that you may need is available freely on GitHub.
And you basically using GitHub to share your code, right?
Yes, I am. I decided to start doing that about a couple of months ago because it's a lot less hassle to have to package up my code and send it to an organizer, because a lot of my sessions will evolve over time. So you know what? I'm just going to put the latest and greatest up on GitHub and just leave it on GitHub. And as I make modifications to it, I just upload it to GitHub. So yeah. So again, it's a lot easier for me, and it also is a way for me to secure my code, in the cloud somewhere. So. It serves several purposes and makes life easier.
And GitHub can store PowerPoint slides as well.
Yes, because it's just a file. So I only store my scripts up there because my PowerPoints also evolve over time. But in this case, who cares about the PowerPoint? There's really nothing in here anyway. So.
Got it. And GitHub account is free?
Yes, it's free. I'm not paying a dime.
Okay.
So there are certain limitations with free accounts, but I'm using it in a very primitive way. I'm not doing any advanced stuff with it. So again, it's just a very simple repository for my personal purposes.
Got it. Andy, thank you.
My pleasure. Thank you again for having me. It was a lot of fun. And I'd be happy to do this for you again sometime in the future as well. So you know how to get a hold of me. So.
Sure.
All right. So with that, I will stop sharing and let's see. All right. I will sign off and say again, thank you very much. It's been a pleasure. Much appreciate your time. So I hope you all enjoyed it. Have a good night. Cheers.